Welcome everybody to today's Accendo Reliability webinar. This is Fred Schenkelberg. And right up top, I'm going to mention that it's raining really hard here and it's supposed to get windy. And that's usually not a good combination where I live for having power and or internet. So my apologies if we all of a sudden drop. It usually means that some natural event or car accident or something like that is taken out the lines. So hopefully we'll keep my fingers crossed that that's all going to work. A couple of months ago when I had to cancel because of lack of utilities, somebody suggested that I wasn't acting like a reliability engineer and didn't have enough backup. And they suggested I get a satellite phone so I could always broadcast even when I lose cell service and internet cabling. Well, in the 8 years I've been doing this, I've only had technical difficulties a couple times, and that was the first time in 8 years. So I'm not really sure the investment in the cell phone is going to be worth it for the next, maybe it'll happen once again in the next 8 years. So apologize for the inconvenience if you were involved with the one back in January. And I'm hoping, keep my fingers crossed that today we don't need, that I'll have to eat my words and hope that I had a satellite phone in order to keep going. But anyway, welcome everybody. And today I'm going to talk about the basic steps of building a reliability plan. And this is aimed more at building a plan for a product reliability. If you're helping somebody design a new product or system, many of the same steps and functions, though, apply if you're just trying to improve your reliability program. So you could be in a facility that's looking at how do I, what are the priorities? What do I need to do? What are the tools and techniques we need to use and apply? And it'll give you a structure for thinking through that. And so that's what I'm really aiming for today, is to give you a process to deal with creating a plan. And then I also want to talk about some of the obstacles or barriers that are in the way. And as Carl Carlson often says, is you got to start with the end in mind. And I think he's quoting Covey, Stephen Covey. And if you don't know where you're going, you know, wherever you go is fine. And you just have to be happy with wherever you landed. Having a clear objective of where you want to go is important. And we'll talk about that at a bit more of a length. Yeah, I just got a Rudolph saying that this presentation slides, well, they're on screen. I hope they're on screen. It shows that I'm sharing my screen. And I don't have a copy as a handout made available. So somebody else, do you have the slide on the screen? We can see them. Okay. Yeah. Sorry, I don't have Chris always does a workbook, which is great. I don't have that, and I didn't make a PDF copy of this one. So sorry about that. I saw another comment there. It was, and I will be sharing the slides later. Maybe I misread that on the Accendo site. That will be available there in the day or two. Webinars are great, but not life or death or miss. Well, Robert, come on, give me a break here. I hope they're useful for you. Yeah, I agree, not life and death. So anyway, you got to start with knowing where you're going. And well, I don't want to give away the whole presentation, but we'll talk about trying to set the vision, the objective, the goals, those kinds of things is important. And then you create a plan. And that sounds magical. And until Carl and I started talking about this some years ago, and what exactly goes into developing a plan. And I'm going to talk about a handful of the things that are just critical to keep in mind as you put together, well, what is it you want to do? And also what it's not a good idea to do it. And then more importantly is you got to actually do it. The best plan in the world is not very useful unless you actually go about actually making it happen. Now, Usually once you start executing the plan and start actually making things happen, things change, and that's okay. A good plan is also flexible and has mechanisms to take into account the changing circumstances. So it's plan and execute sounds really a lot of fun, but there's more to it. We'll certainly talk about that. And then there's always obstacles. There's things in the way. There's people that just don't get it. And I don't know how many of you have had the discussion with somebody about what HALT is. And well, of course it failed. You overstressed it. And how to interpret that to just ship it. We don't need to know if it's going to work or not. To lack of resources. I think everybody here has dealt with not having enough samples to run the test appropriately and so on. There are plenty of barriers. We'll mention those as we go through. So there's always a process, whether we recognize it or not, but what process do you use? How do you go about creating a plan? What's the common technique that you use? Yeah, timeline is a great barrier. I remember the very first project I worked on was in reliability, was an accelerated test, and they wanted to know if this product would last for 20 years. And I thought, well, if I get 21 years, I could answer that question. And of course, they wanted an answer in 6 months. So, okay, allocating the goals, breakdown, yeah. Risk, that's a good one, Robert. You'll see some of that coming up. Good, good. And hopefully nobody's writing it down, but the idea is that the common plans I've seen or processes is, well, what did we do last time? Let's do that again. And it's a start. It gets easy adoption, usually from the program, unless I'm sitting in the room. But it's, and Chris Jackson says it oftentimes, is we're reliability folks. You don't check the brain at the door, right? This is part of the process of thinking through what we're doing, and creating a plan is in part helping the rest of our organization think through how they're going to achieve their objectives, what they need to do. But criticality and risk, following a development plan, Sebastian, you're putting out there, the V&V process that we follow. There's product lifecycle documents that outline different various steps from concept through to retirement and so on. There's lots of different ways to go about doing it. And what I'm hoping to talk about today is more of a framework of how to think through that. What are the critical elements that you need in order to build a useful plan that you can actually create a lot of value with? Knowledge gaps in the project. Yeah, Pramod, that's a good one. There's a lot of that. I learned in consulting years ago that you got to start with a client or your customer or your team, is start with where they're at. Don't ask them to build a rocket to the moon. Well, of course, some of you might be doing that. If that's not in their bailiwick, that's not what they do. I've noticed that. I'm getting revved up for St. Patrick's Day. Bailiwick, I think, sounds Irish of some sort. But the idea is that start with where your team is and build on the strengths and shore up the weaknesses. And that's part of the overall process. I don't think I've got too many notes on that specifically, but here, let's see. So as I mentioned at the start, you got to start with the end in mind. And Chris or Carl Carlson mentions that quite often, quotes Covey with this in mind, because it's so vitally important. And I'm not talking about the corporate mission statement that's like a small fancy plaque on the side of your conference room wall and nobody ever uses, or touchstones. It doesn't mean anything to anybody. It's kind of corporate gobbledygook. What I mean is, we need to sit down and talk to, not our boss, unless it happens to be the CEO. We need to talk to the folks that are in senior management that oversee, say, the engineering team and the reliability performance that comes out of it, or a VP that's of quality and reliability, or as senior a person as you can sit down with and say, what are we trying to achieve here? In the long view, what do we want to position our company to be? The reliability leader? Do we want to be middle of the pack? Do we want to be as good as or better than somebody else? Do we want to minimize warranty? Do we want to improve customer service? What is it that our company and our brand is associated with when it comes to the reliability performance of our products and systems? And from a asset management or facility type view, is reliability can take on many different facets. It could be the quality of the product you're putting out, the consistency of it, but it also could be avoiding latent defects in your product. And then more commonly, it's, well, what's the uptime? How do we get our production going such that we minimize the costs associated with unscheduled downtime? But you need to be very specific in the long term what we're trying to achieve in order for you to set the near-term types of plans and activities for the specific program that your project that you're working on today. If each of us goes off in a different direction, or each program or project is got, one wants to be best in market and the other one doesn't care, and the other one is off in the weeds and doesn't want to pay attention to reliability at all, is seeing that as a cost center. Well, we don't have a guide or a touchstone or a vision is the right word for it, of where we want to go as a company. And sometimes that conversation with those senior managers is they don't want to talk about it either, as they hadn't thought about it yet. And sometimes you find a champion that really wants somebody to focus on it and run it forward. It could go many different ways, but you need to have that discussion right up front in order to be very clear what you're trying to achieve and how you go about getting support, which is another key part of it. I see a couple of questions coming in here. Yeah, it allows us to manage expectations. Exactly, Robert, is if we understand where we're going and we have senior management cover or support for that, it makes it a whole lot easier to overcome some of these barriers of, well, that's not our job, or that's not in our mission, or that's not what we're trying to achieve here. Well, no, we have it here in writing. Yeah, definitely, Carl. We need to be clear. That's what I'm getting at here. I see some of your questions. Need responsible leadership. Leadership can't delegate responsibility. Well, not just leadership. Any of us can be leaders in getting things done and getting a team to follow us. That's not the hard part. The hard part is that senior management that has a role to play with leadership of the reliability program, it's not possible for them to delegate their responsibility. At the end of the day, the senior management makes decisions about all kinds of things. And if the product is crap, then it's their fault. There's the buck stops here kind of attitude, in my opinion. But that's why they get the big bucks, and that's why they take those risks, and that's why they're making these decisions. That comes with the territory. On the other hand, they can delegate authority, right? You can get budget and direction that then says, hey, go make these things happen. And that's what we're after when we go talk about vision. Is one of it is part of understanding, but two of it is authority to take action to try to achieve that vision. So those are big parts of what we're after when we first start with, well, what are we trying to achieve here? Now, this gets complicated when senior management changes, right? They may have a completely different concept of what they want to happen with reliability. And it's, again, a time to have another set of conversations to sort that out and fully understand it. Now, when you get to a specific program or project, let's say you're designing a bicycle, for example, Well, part of this is, well, what's the program trying to achieve? What's that particular market? What's that particular set of circumstances? And for this round of activity, what is it we're trying to achieve? And the concepts of the conversations at this point become much more focused to that particular realm. Now, back when I worked at Hewlett Packard, we had, I was supporting 3 or 4 different projects at one time, and each project had a different objective when it came to reliability and quality because they were in different markets. Some were low cost, intro type products, and some were high performance. And so one was focused on availability because it was working with competing with offset printers, and it was industrial essentially, whereas others were the very low cost, easy to use home printer that it costs more to buy ink for it than to buy the printer itself. So it was keep the printer running long enough so that they buy more ink. And it was a very different focus for the reliability mindset, but one would put lots of expensive parts and do lots of testing and do all kinds of cool stuff to make sure it would work, where the other one was, we don't have the budget for that. If we spend all that money, we won't make a profit on this program. And so understanding, is it time to market? Is it cost? Is it the highest possible quality or not? What are the sets of constraints that we need to work within as we set this objective? And it could be all kinds of different things, but understanding it in some detail so that we can write a very clear reliability statement for that project or program. And I know I've talked about this before in previous webinars, and I know I've written about it a number of times, but there's 4 elements, right? What is the function? Let's say it's that bicycle. It's going to be a road bike for the Tour de France, circuit kinds of folks. Very high performance, very lightweight. There's probably a whole document full of specifications of how much power it would transfer, how much flex it has, all kinds of weird stuff. And almost always it's for high performance bicycles, it would be weight. It's got to be very lightweight, but very strong. But it only has to last the race. And even then they carry spares with them so they can throw the rider back onto a new bike if the one they're on fails. So they give up some of the reliability elements of it for robustness and lightness. And so understanding the function, the primary functions, and writing it down, and then referring to the full stack of specifications that are required. That's the primary function. We got to know what we're trying to do, because if it doesn't do that, that's a failure, right? That's how we define what a failure is. If it survives that, it does the primary function for this duration, then we're getting somewhere. The environment in use, right? Is it going to be in the mountains in France, or is it going to be on cobblestones? Is it going to be ridden extraordinarily hard with lots of stresses and forces put on it, as compared to a beginner's bicycle for a 10-year-old? The environment is specific to that product, and not the general weather in Europe. It's the weather and road conditions and stresses that product sees during a pro bicycle race. So the environment needs to be very specific. And again, we tend to summarize it in this reliability statement and then refer to other documents for the details. And the details got to be specific to this particular product. And like I said, not just the weather conditions in Northern California or outside your office, but to where your customers are going to use and how they're going to use your product. And then our favorite part is the probability of success over some duration. Now, you notice there's 4 elements here, and it's not as good as or better than the last time. It is not, well, we just need to make it a 5-year product. Well, okay, 5 years, but half of them fail in 5 years? Under what set of conditions? So I've seen reliability goals in so many different programs summarized to one number or one word or a duration only, or as good as or better than the last time, but we don't know how good the last one was, so it's kind of meaningless. I know I've talked about this at other times, but be very specific and get yourself a complete reliability statement in agreement with your program so that you all know exactly what you're trying to accomplish in the big picture. And then that technique of breaking down the goals, the probabilities and what stresses you're seeing and stuff becomes much clearer to shaping what you need to do for a reliability plan. It's not the only part. It's a critical part, is this start with the end in mind. Yeah. So Robert's mentioned it's the, oh, Brent, let me go back to a couple of comments here. Brent's saying, why all the images of fences? Those are the barriers. No plan we ever make is without obstacles. And that's what I was alluding to here. And it's also a reminder to me to talk about these barriers. So Robert's saying, if you have a 5-year life, what typically do you design for? I don't know. I actually talked to a team, and I know I've talked about this story on podcasts a number of times, I was interviewing them as an assessment. We'll talk about that in a minute. And there were 3 electrical engineers, 2 engineers and their manager sitting in one row. And I talked to the first person, she said, and I asked her, what's the reliability goal? And she said, it's 50,000 hours. Or no. I'll use the example. She used 5 years. I says, that's great. What does that mean to you? He says, well, that's really difficult. Our products, under extreme stress, it's really hard to get good parts. We have to buy the best we can. I make decisions to use the most robust products and do lots of derating and make sure do lots of testing is what I expect we need to do to achieve that. Oh, okay. Well, that's informative, but then I talked about, well, what are the use conditions? What's the probability, how many need to survive that 5 years and so on. And that got not clear. She didn't know. Next person I talked to, and I asked him the same question, and he said, well, 5 years. I said, well, that's good. They both have the same number in mind. That's not always true. And I says, what does that mean to you? And he said, well, it's a piece of cake. It's not hard to do. Our parts are pretty robust. We've never really had an issue. So I don't worry about it at all. And I can use cheap parts and cheap vendors and so on. So I knew they were both working on the exact same circuit board and different elements of it. I think one had more of the power supply area, one had more of the logic area. Well, this is curious. They're looking at this in a completely different way. And the third person was the manager. And she said, well, it's 5 years, but we don't measure it, so it doesn't really matter. And so the setting the goal of and making it just to 5 years and what are you going to design to can vary dramatically unless you have a better picture of what's the complete objective. What is it you're really trying to achieve, both from a vision point of view and for your specific program? And then where are you have problems achieving it? Do you need better information? In their case, they just needed to measure it and it give them some feedback, but they didn't know what to measure because they didn't have a probability statement on this thing. They didn't know if they were going for a 60% reliable over 5 years or a 90% reliable over 5 years, which would dramatically change the approach to the design decisions they make. So making a complete statement goes a long way to help you and the team get it all together. Right? Let's see, I catch another one. As I train, reliability is the probability that a product will perform its intended function for a stated period of time under specific conditions. Yep, exactly. It's on page 1 of the O'Connor and Kleiner book on practical reliability engineering. It's the classic definition, but it's 4 parts. And in practice, we summarize it way too often to just, it's a 5-year product, or it needs to be 5 nines reliable or available, or it's got to be robust, or some other subset that, unless it's understood across the team what the other elements are, it's usually not all that useful. So flushing it out completely is a big piece of this. Carl's mentioning product liability. Part of the leadership team, the senior management team, in some cases, when the product goes really bad, can have personal liability on this. Product liability of making it right, and from warranty and legal and regulatory requirements and so on, is a factor. It's one of the many considerations and constraints. It's not usually a useful reliability goal to say, oh, we're going to minimize liability. Well, that's easy to do. Just buy insurance, right? Or don't ship the product. Yeah, exactly. The Pinto disaster, and there's many others where I am thinking of the airbag igniters or whatever that device was called, and kind of going off when they're not supposed to go off. That ended up being quite a fiasco. All right, so that's the complete statement. So this is I won't put you on the spot, but can you state your goal in that exhibits all four elements? And is it commonly understood across your team in that same way, all four elements? If not, then we got some work to do, because we're generally then not on the same page. Now, it may, depending on the culture of your organization, you may be perfectly fine. But in my experience, most organizations that don't have a clear picture of where they're going and a clear statement of what their objectives are for the particular program, there's a lot more barriers artificially put in place just because each person will fill in the blanks and will create their own goals or ignore it or all of the above. So be very careful about being very clear about what the goal is. Put it on page one, make it all four elements, make sure people understand what its ramifications and all the extra resources that go with fully understanding it, the full set of functions and the full set of environmental details, so that they have the information they need to fully understand what we're trying to achieve. So I got out of the fences. Now I got some doorways and, well, some more fences. So part of the process, once you get a good idea where you're going and you get started with the program, is, well, where are you? What is possible right now? What is this team good at? What are they not so good at? And what do they understand and don't understand? Do we have, are we doing a cost reduction on an existing product and we have lots of field information and lots of failure data and cost data that we can use to inform us? Or is this a startup and we have nothing except our experience from other different types of technologies and products and designs that's not exactly in this market? What do we know and don't know? Where's those barriers to helping us achieve what we're trying to achieve? The assessment is part understanding the culture of your current organization, the strengths and weaknesses for sure, but also with an eye towards, well, what is it we're trying to achieve? If we come to the understanding, they say, we really need to understand this. Will it last for 20 years? And the question I always ask is, well, how would you do that? And they say, I don't know. Well, there's a barrier. There's a piece of capability within the organization that's not quite there. And so that it suggests that they have a gap. They want to know if it'll last for 20 years, but they don't know how to do that. Well, as reliability engineers, hopefully you have Wayne Nelson's book on accelerated testing on your shelf, and you could open that up and design a suitable accelerated test to help them answer that question and to help them understand, will it last 20 years or not, make that decision. But the assessment is I found in many organizations that it's the first time somebody sat down and with a series of interviews said, what is it you do to achieve the reliability that you achieve? Is it a random process or is it a deliberate process? And if it's deliberate, what is it you specifically do? How do you use the information that is generated from your environmental testing? How do you use the information and how consistent are you at selecting vendors that meet your reliability requirements? What I found is very few people go around asking those kinds of questions, but doing it takes a day or two talked to a handful of people for a while in mechanical, electrical, software, in the management teams, in quality teams, manufacturing, and understand how reliability occurs is a great way to understand where the strengths are, the weaknesses are, but more importantly, what's the culture? How does this organization do reliability? And that's a key part. Let's see, got a couple more comments here. Oh, good question here is, how do we differentiate product goal from a test requirement? Well, a goal is not a test requirement. If I say I need to pass this test, okay, so how does that translate to that we're going to have 90% reliable at 20 years for our product? How does that test actually relate to our objective? So you can have tests all day long, but unless you have a goal and a vision or an objective or a statement of what you want that population to do, you have nothing to compare it against. I might run a test and have a failure and go, oh, okay. Well, if I don't have a clear goal, I don't know if that means it's good or not good. Passing or not passing a test is really how good you are running experiments and what kind of experiment it is. If you're doing a halt, you want lots of failures. But we also know that halt doesn't translate to it'll last for 2 years or 20 years. It repeated running of halt and doing the improvements based on what we find will make it more robust and generally makes it more durable and last longer. But we don't really know from that experiment how long it'll last. On the other hand, if we do an accelerated test, that almost always requires us to focus on a particular failure mechanism. Well, every product has got hundreds, if not thousands, of potential failure mechanisms, different ways it could fail. So we don't really know from one accelerated test focusing on, say, solder joint cracking, that the rest of the product is going to be okay and how long it'll last. We know about that solder joint. So we have to be very careful about what the test is for and what we're trying to achieve, but setting an objective that we're going to pass this test or has to work at 40C without a foil of what we're trying to achieve is giving you information, but you have no way to judge it. 40C might be, that's the sweet spot for where our customer is going to use this. So the majority of people are going to use it at that point. Or it's an environmental spec saying it has to work up to 40C. But if only 1% of people actually ever achieve that of use of our product, well, if we have a failure there, is that meaningful or not? What's our goal? If we're trying to do 99.9% reliable for some duration at that environment, then one failure out of a sample of 10 is devastating. But one failure out of 10 when it's doesn't impact the overall results of our product, I'd say it. So that's my point, is that the test results have to have something to compare it to in order to adjudicate whether it's a good result or a bad result. And it also goes into how we set up the testing and what kind of testing we do. So hopefully I answer that. Let's see, another question. Automotive 90 or 96% reliable with confidence 90%. Yeah, so keep in mind that as soon as you put a confidence in there, you're talking about a sample. We use confidence to suggest the typical type 1 error confidence bound, confidence range, confidence interval. That implies that you're saying, I am going to set it, I'm going to have a sample from the population and I'm going to test them. And the confidence is related to that the probability that our sample is reasonable representation of our population. A goal is for the population. There's no confidence in that. It is what it is. If the objective is that this bicycle needs to be no more than 1 pound in weight, it's a feature of the population. right? Now, we might want to make it a little bit less because there's going to be variability, but what's the goal? The goal is we want it to be 96% reliable over 10 years with the function and environmental constraint elements to it. That's for the population. The goal is for the population. Now, if you're doing a test plan and you're doing some creative way of testing it that you can test the whole system or that critical function that you're looking at, and you only get a sample, vast majority of the time we get an inadequate number or sample, then confidence plays a role in helping us interpret those results of that experiment. But a goal should never have confidence in it because you're setting a specification for the population and not for the test results. So you might set a policy that for critical functions, we're going to do 95% confidence for any of the experiments we run. But what if you don't run an experiment and you're using historical data or vendor data? How do you put a confidence on that? And so it gets more complicated real quick, but a goal should never have confidence in it. Yeah, who drives at 22 miles an hour? Somebody figured out that that's probably the average because vast majority of the time a vehicle sits in your driveway or the parking lot. And but anyway, I digress. I had a conversation like that with somebody and he said, the vast majority of the problems with cars is not when it's running, because it spends so much more time just sitting there. So things like dashboards failing due to UV radiation, doesn't care whether it's driving or not, but it's usually just sitting there. So yeah. I don't know. Could a Model T max out at 20 miles an hour? Depending on the roads. Around where I live, the roads will keep you going slower. Yeah, and Pramod, you're getting to the idea that I'm going to get to here in a moment. This assessment is part of it to understand what we know and don't know, but we also need to know what we need to know and what is the pieces of information that we need more clarity on. So let me get to that here in a moment. I think there's a bunch of statisticians in this group. I'm enjoying the comments. Well, yeah, Maximilian, I'm glad it helped. And if any of your team members have a question, have them send me an email. I'll be glad to discuss it more with them. That'd be no problem. All right, so we run an assessment. We understand where we're at, and now part of that process for this specific project is we need to figure out, and I haven't seen really anywhere else. I know Chris and I and Carl and a few of us have talked about the importance of building a reliability plan that actually helps people make better decisions. You need to understand where you're going. That's a decision of what we're trying to achieve. Somebody decided we're going to be best in market and we're going to be in the road race, professional road bike circuit. That was a conscious decision to create a product that meets those requirements and will fit within that marketplace. But then we also have to make decisions about, well, is it good enough? Will it meet the requirements? And somebody's almost in every program or project that's developing a product or is turning on a production line is it ready? That's a common question. And somebody needs to decide, usually the program manager or the ops manager is going to decide, yep, turn it on, or no, we need more time to get this right. Now, in order to make that decision, they need information. The better your information, the more complete your information, the more likely you're going to make the right decision. So think of it as, is the reliability good enough that we're going to meet our warranty targets? Now, if we have no information whatsoever, you might have like a 50-50 chance of making the right decision. You ship and it might meet the requirements or it might not. And then you have the consequence of all the extra warranty or all the good sales. So there's a pros and cons there. But at the other hand, if we got some decent information that we went out and measured a variety of elements of our product, and we did modeling and we did all the right stuff to inform that decision, we may shift that probability of making the right decision to say 80% of the time we make the right decision. We either delay to improve it because we're not there, or we ship it because we know they're there. And that shifts the net value of that decision from 50-50, it's good or not good, and there's benefits and there's downside, to we maximize the probability of the good side and minimize the chance of the excess warranty. That has value. And so the idea is what are those key decisions? And then which of those decisions need reliability information in order for it to be improved, the ability to make the right decision. Now, it's not that we know or not know ahead of time, are we going to design a product that's going to meet our goals? There's a lot of wishful thinking that usually goes into that. And you may have a long history of actually achieving your goals over and over again. So it's not critical. Is it good enough to ship? We've got this. The problem is that when we end up with a new vendor or new materials or a new design team, some of that chips away. We're not as sure as we are in the past. But the idea is it good to ship is just one of many decisions. Which vendors do we use? Which production facilities use? What kind of welding techniques are we going to use? What kind of finishes and coats and paints and so on are we going to use? There's decisions all the way through in creating a product or starting up a production line. And which of those decisions are vital to achieve the reliability objectives? That's the key part of this assessment, and then follow-on interviews and focusing what we pay attention to as we develop a plan and modify a plan. What are those key decisions? Now, the example I used earlier of that accelerated test for 20 years, I asked right off, one, if I could go to Italy where the product was going to be used for 20 years and see if it works. And I said, no. I said, why do we need to know this? He says, the customer won't buy our product unless they have evidence that it will last for 20 years. Oh, okay. So there's a buy decision involved with this that's critical to this new product we're developing. Yes. All right. Well, I'm off to go figure out how to inform that decision. And part of that was asking the customer, well, what do you consider sufficient evidence? You know, is it modeling, understanding the material set, tensile strength? Do I need to actually run an accelerated test? And they said accelerated test, that it would work. So then I was off to design my first accelerated test. But part of it starts with, well, what are those decisions? And some product life cycles and like the V&V type stuff and so on, give us a set of criteria. These are the types of decisions we need to make at these various stages or checkpoints. But if you're going to run a test, does anybody need that information to actually make a decision? Or is it just going to go into the records? And then for what purpose? So this is a critical step in order to understand how you make your plan valuable. If I create a whole ton of information, I run 47 different tests and nobody understands what they are or what they're for or why we would ever use them. And we spend most of our time explaining why this is good or not good. And well, we would just wasted a lot of time, in my opinion. If we've got 25 key decisions that need to be made, and I'm going to run this experiment or create this model or so on, in order to inform the decision makers, then I've got a direct link to something that's of value, that's useful. Somebody needs that information to do their job well. And we have the skills and capabilities in the reliability world to create that information, or to gather that information, to present that information. That's key in order to tailor your reliability plan. Now, just understanding the decisions is just one step in this part. Now we need to prioritize it, because as I alluded to, there's thousands of decisions that get made all the time in creating a product. And people are going to make decisions that have a huge impact and have a huge risk. to, which vendor are we going to use for the aluminum that we're going to put in this bicycle? Or are we going to try a new carbon fiber composite that's never been used before in this market? Well, that might have a major risk to the project. It may risk the chance that we even achieve our goal or the objective, right? What's our reliability, vision, and goal? Will this threaten our ability to do that? And it could be just, we don't know. We don't know if this carbon fiber will be better than the one we've been using. So that might be a very high risk to the project's ability to achieve its goal. And then, but if it's easy to figure out, right, we can run a quick experiment, or we know how to address that. We know how to get that information, and it's not difficult to do. Well, we'll probably add that to the list. It's important to the program and it's easy to do. Cool, let's do that. The quadrant 1 stuff is a way to look at, well, those are the easy low-hanging fruit type stuff. Let's do those. They have a big impact and we can do it. But the other high impact ones, like that accelerated test I mentioned for this customer, is I didn't know how to do an accelerated test. So that was a bit more difficult to do. And we knew after not much work that it was going to take us 4 to 6 months to even get results from a test, given the nature of our product and how we could accelerate it. So we knew that that was going to be difficult. Now, one good thing is we had plenty of samples. So that was a joy to work with, which isn't always common. But you take a look at the difficulty to address. It could be the timeline, which may run into time constraints, or the cost, which affects your budget, or do people understand the results of this? You could do a really exotic, really interesting, very technically accurate experiment, but if nobody understands it, how are they going to make a decision based on those results? So list the decisions and then do the ones that make a difference first, and then do the ones that are easy to do, the piggy tail, or right on the same experiment. I might get results that are have lower risk to the project, but if I do this environmental test that's focused on the high risk topic and decision we need to do, it may provide collateral information that's useful for a bunch of other things. But if you don't understand who you're trying to inform and what information they need, it's really hard to prioritize, what am I trying to do in this project? What am I trying to achieve? So a key step is understand who needs what information, and then go about saying, well, there's lots of ways I could do this. I could do modeling, I could do simulations, I could, run this experiment, or I can run this accelerated test, or I could do this combination of things. I could do this waterfall, I could do this and that, and all the other stuff. There's always lots of ways to get information. Some will be more accurate, some will be more expensive, but it allows us then to focus on what we're trying to achieve, not which tests we're just going to run. I hope you see the difference between, I'm not going to start with a bunch of tests I want to run or a bunch of modeling I want to run. I'm not going to start with always do FMEA and HALT and do a model. They show up in a lot of things because they actually do add value in many cases. But if you're just doing them because that's what you just do, well, the chance of it lining up with what information people actually need is reduced. So instead, focus on what people need to know. Oh, I hate seeing that, Sean. MTBF over 10K hours. Oh, good luck with that. Yeah, exactly, Chazelle. And sorry if I'm not pronouncing that right. But yeah, once people understand what MTBF is, it's usually an eye opener. And I actually had a customer tell me, we use MTBF because it sounds better than it's 80% reliable over 3 days. I said, well, they're going to find out one way or the other. I don't agree with you, Cristomo. The reliability number is the proportion to survive over some duration, right? It is a probability. It's a number between 0 and 1. It's the chance of survival over some duration. And that is by definition a probability. And the uncertainty, the confidence level is a measure of that sample's ability to, in a crude way, to represent the population, assuming you've got a perfectly random selection from the population, which we almost never have. It's often used as a trade-off to say, well, how many samples do we need? Well, if I go with a lower confidence, I can use fewer samples, but you're getting less information about the population. You're less sure of where that sample is actually representing your population or how well it actually represents it. So be very careful about connecting confidence to probabilities. If we're talking about a goal or about the population, there's no confidence. It's the population. Confidence in the common way we use it in the type 1 error realm, or even type 2 errors, is related to how well that sample addresses the information that's available when we look at the entire population. So it's got a completely different role than defining the probability. That it doesn't connect there. You might have to, and I know Chris did a whole webinar on confidence, and so that might be something to take a look at. So anyway, back to decisions. We got lots and lots of decisions as prioritizing. Now this 2x2 idea is not mine. It's one of many different ways you can prioritize it, but it came from, oh, now I'm drawing a blank on his name. He's one of the podcast hosts. It'll come to me. But it said, you know, well, which ones are most damaging or most highest risk or whatever is important to your program, which would preclude you from achieving your objectives. And then how easy is it to do? It gives you a way to prioritize it. Now, each team may set up a different prioritization technique or realm. You might use something varied off of an FMEA or a hazard analysis or some other technique to prioritize it. But take a look at which of these decisions, the many thousands of decisions that are possible, which are the ones that we really need to focus on, right? And it also has the added benefit that it'll help you get funded for it, because if people want that information, because they know they need to make a decision, they're likely to give you the samples and time and space and resources to actually go get that information. So it has that double advantage. It helps them, but it helps them help you. All right. Oh, I'm drawing a complete blank on his name. I'm having a senior moment here. Anyway, so the next step is select the methods. And again, as I mentioned earlier, is that you don't start with, here's the list of things I'm going to go do. That's silly. If I knew what I needed to do, then, you know, and it's the same every time, well, I'm fooling myself. Each program, each system, each thing we're working on, each project we work on is unique. There's no doubt about it. And we have a different set of talent within the team. We have a different set of materials. We have a different set of vendors. We have a different set. There certainly is going to be overlap. You know, if we're doing an iteration of a product and there might only be 1 or 2 changes. Well, does it make sense that we focus on what the 1 or 2 changes were from the last time? Or should we focus on this time? And also our time constraints may be different. Our budget is probably different. Our resources and capabilities are different. We learned stuff the last time and we can build on that. We learned about the ins and outs of FMEA last time. And if it fits this program to provide suitable information, which it may well do, we can build on that and extend our capability in that realm. The hard part is that I see too many programs where they say, well, we've got a thermal chamber. It's a temperature humidity chamber. So every program we run samples through that. And I ask why? He says, well, we have the resources, we need to use it. No, you don't. The humidity chamber works great without the humidity as just the thermal chamber, if that's what you need. But you need to back up and figure out, well, what is it you need? What information is necessary to help people make better decisions? And I think I've said this a few times in today's presentation. But the first step is go back to those decision makers and say, well, what do you need? What will help you make a better decision? And help them be specific. What is it they need? Do they need a Bible plot? Do they need a exhaustive test that gets us to 99% confidence? And then you tell them how many samples they need, and they'll usually back away. Do they need just vendor data? Do they need the material testing and characterization? What is it specifically they need in order for them to make a better decision? And this is a conversation. It's usually you got to help them understand what's possible from the range of different tools and methods we could use and what kind of information it could provide. We can do a quick and dirty, and that might be good enough if it's not a high dollar value consequence if we get it wrong. On the other hand, if it's $1 million decision, they may well want the more precise, more exotic kind of method to get to the very good results. But be very careful about not offering only the things we have assets for, or we know how to do, or we're comfortable with. You know, that old adage of if the only tool you have is a hammer, everything looks like a nail. This is the point to figure out what tools and techniques or measurement equipment or tech or methodologies will best suit the decision that needs to be made. Not, we're going to throw it in the chamber, we'll be fine. So be aware of all the various methods that are available, and then start figuring out, well, what kind of information can they provide, and will that help inform those decisions? So all of these come with trade-offs, right? We run into this all the time. We're going to say, well, this is the perfect tool. We need to do a 18-month full-on acceleration test characterization and create our own model. It's the best way to go about doing it. And they're going to say, whoa, we only have 6 months. Well, I can do a quick and dirty. I have to make some more assumptions. It's more risk. The test might not actually represent the population, but given 6 months, that's the trade-off. Or it could be cost. Well, you can't have that many samples. We're only going to make 100 total ever, and you can't have 118 samples. Okay, well, we're going to have to give up something here, right? You're not going to know if it's going to last for 5 years with this probability. So what will help you make a decision that it's actually useful? Well, let's do halt and hope we find some of those big hitters and make it more robust. Okay, let's do that. We get to inform that decision in a different way. There's lots of trade-offs, and that's just reality. And the hard part, though, the real barrier is that somebody will put another barricade in front of you halfway through the program saying, oh, no, I need to send those samples to customers. You can't have those. Or no, we got a budget cut here. Our bank just had a run and our funding's all gone. So we have to cancel all of the contracts with the test labs that we've been using. That's kind of a barrier, but it happens, right? So we need to respect that and be flexible in adjusting the test plan and the types of information we're creating for the current conditions, and stay in touch with those decision makers, the people that are expecting those results, to understand circumstances of change, right? Let's figure out where we're going now. The plan itself, even well-written and documented and spell-checked and everything else, is of no value other than helping your team understand what you're trying to do, unless you actually go do it. So actually go run the tests, go build the models, go monitor and track information, provide the information. Now, I would add one piece that I didn't put on this slide is also capture how useful it is. Was this $1 million decision and your information really changed the ability for them to get it right? Well, quantify how useful that was. On the other hand, always be on the lookout for what's changing. Oh, we're going to bring on a new vendor. Well, is that a high risk proposition to achieving our results or not? Go back to that prioritization process and says, does this decision make a material difference to us achieving our objectives? And if it does, well, you might have to adjust your plan given your amount of constraints you have in order to address this new important thing, or vice versa. That decision is mute now. It doesn't matter. We've moved on. We'll stop that program or that test. Just because you started the test doesn't mean you need to run it. It may have value for other things, but if it's not a high priority one, and you've got plenty of other things you should be addressing, well, reallocate, adjust. All right. And I'll leave that up there as a generic ad. Some of you may know that we just got a book out that talks about this 6-step process that I just basically sketched right here today. It's available Amazon, Barnes & Noble, all kinds of places. Hopefully you enjoy it. And it goes into much more detail. Some of you have actually, I know some of the names on here, I've seen the drafts of it when we were trying to get the book in good shape. And we got, I don't know, it was probably close to 500 or 600 different comments of everything from spelling errors to, hey, you're missing this topic, or I don't understand this piece, which really impacted the final result of this book. So to those that actually helped us write this thing and gave us feedback early on, thank you. It was most appreciated. And I think it made for a really good product. But Carl and I collectively put together this process of understanding where you're going, understand the lay of the land. What do you know and don't know? What do you need to know? What are those gaps, basically, is the way we phrase it in the book. And then how do you actually focus on what you need to do? And that's the prioritization of the decisions. And then as you get those decisions, you get many options of how to inform them. Well, given the constraints, it usually makes the choices pretty easy. So that's the way you build a plan, and then go do it. Keep monitoring, keep adjusting, keep tabs of what's going on with your program so that you continue to focus on what's most important and use your resources appropriately. So that's the idea. Let's see, there's a couple of comments here. Let's see, let me catch up. A couple of units about MTBF. Oh, that's all good stuff. English class, where Maximilian teacher made us create outlines for the essay. The outline itself doesn't contribute to the essay getting done, but it sure makes if you don't have it, but otherwise it's directionless. Yeah, well said, I think. I probably read it too fast. But the idea, Maximilian, is that the idea that Carl and I are proposing in our work and in this webinar is that there's a framework for how you go about picking what to work on. And Carl and I came to the realization a while ago is that when we get to know an organization and we understand what they're trying to do and what they're going after and where they are, what they're capable of doing, we often then would jump straight to, oh, you need to do these 3 things, this test, this process, do this model, that'll help you. And we came to the realization that that was built on our experience. We jumped to the solution and we stepped back and spent quite a bit of time trying to figure out, well, how did we do that? What was the process we used that said, oh, you need to do a block diagram? And that's when we realized that we were addressing what decisions did this team need to make. And so that's the key, is understand and prioritize what you do to have the most impact to the organization. That's usually focused on the decisions of your team, of your organization, or of your customers. Let's see. Pramod, trade-off between generic reliability assessment, let's understand what failures will show up, shotgun test, or design specific tests that focus on specific failure modes with specific acceleration parameters, sniper test. Yeah, no, there's a spectrum of, can we go completely analytical and understand and characterize everything? Well, probably not. That's really difficult to do. Or are we going to just make it more robust and find failures and fix them? And that's another approach. Carl and I submit that it's somewhere in between for vast majority of programs, but it's always based on where you are. What are you capable of doing now? And what do you need to know? And then focus on what kind of testing you do. Now, there's different generic things for different industries. If you're building rockets, for example, you're probably not going to get a ton of testing in actual use and get a handful. Like I'm thinking of the Boeing aircraft wings. They created a new composite material for a wing, and they actually tested a couple of them, but one of them in particular to failure. But it was to confirm their modeling. And they had a lot of modeling. They spent a lot of investment doing it just analytically, and then proved that the model was good enough. The idea is that we need to understand why we're out there breaking a wing. If we just do it because we do it every time, well, that's not terribly useful all the time. So if we're doing it very specifically to make sure that we assess and confirm or deny our model, then we would set up a test in a very different way than just going out and breaking a wing. So it's be very specific of any of the funds and resources you expend in a reliability program, that it actually goes to a good use. You know, I walked into one manager's office, a development engineer's office, and he had a whole stack of halt test reports holding his door open. And I said, do you ever use those? And he goes, no, they're only useful for holding the door open because they're great big heavy documents. But I says, why don't you use it? And he says, well, it's full of failures and I don't like talking about failures. We're trying to make a product that works. Okay, well, let's talk about this. But well, Carl, there is this need to know basis, but it's also there's all these decisions and they all would benefit from having better reliability information, but we don't have time or resources to inform every decision. So some of the stuff is specific activities for specific decisions. Now, what I didn't talk about was all of those guidelines and cultural elements that help us understand and influence, like electrical engineers having a derating guideline that actually they use. And that takes some training, that takes having that document available. And it also takes a culture that says, this is what we do. If we're designing a product, an electrical product, we use this guideline. Mechanical folks or material selection or vendor processes, what are the types of questions and techniques we use to understand the risks? That's all part of the culture of an organization, which we can influence, right, in the larger picture. So there's way more to this than obviously we talked about here today. But if you're off creating a plan, hopefully it gives you a step for that. Paper plane sets records. I got to go check that out. All right. Yeah. Well, we're over time. So thanks everybody for participating today, and lots of chats, lots of questions. Thanks everybody for doing that. And thanks for picking up the book. That's cool. And as any of that kind of stuff, if you got a question or comment from this presentation or from the book, do please let us know. As you know from the webinars, we thoroughly enjoy comments and questions. Usually makes for a good episode, but we also sincerely try to get you useful information back to you so you can keep doing what you're doing. Oh, you lucky person, Celine's intern. Hopefully she's not working you too hard. So have a good time and say hi to Celine for me.